So we're going to look at rational functions in a little bit more detail. So the basic setup of a rational function, we call it r of x. It's the division of two polynomial functions. So we could have p of x and q of x, which are separately polynomial functions, and then a rational function is the division of those two values. Now for basic functions, we looked at 1 over x squared and 1 over x when we looked at graph transformations. These graphs are showing that if we just have even powers, what we would see is a very similar form. If it's an even power, we're above y equals 0. We have this vertical asymptote. And then for odd power, similarly, so cubed to the 5th to the 7th, similar shape here. We have these asymptotes coming through, both vertical and horizontal. So we've talked about vertical asymptotes before, but a new piece is going to be horizontal asymptotes. So if we look at this even powers graph, you can visualize this vertical line that will never cross. So that's the line at x equals 0. And that would be our vertical asymptote. So we have a vertical asymptote at x equals 0. So it's a vertical line when x is equal to 0. If we think about our graph transformations, what will move it is this moves with a horizontal shift. So if we have some graph transformation that is moving things to the right or to the left, that vertical asymptote will also move to those locations wherever we end up. Now, with a vertical asymptote, it's a line that we never cross. So that's something that comes up with it, is that we never cross that line. With a horizontal asymptote, that's not necessarily true. It is true in these cases that we're seeing in these graphs, but just keep in mind in some future problems we'll look at horizontal asymptotes and the graph will cross it, but that's okay. So just keep that in the back of your head for now. For these problems that we're dealing with in this video, we're going to have a horizontal asymptote that we're not crossing. So we have this horizontal line. So we call this our horizontal asymptote and so since it's a horizontal line, this will come from y equals, and in this case it's coming from the line y equals 0. So that one is going to move when we have graph transformations with a vertical shift. So if we're moving our function up or down, then that horizontal asymptote will move along with it. And then, like I said, just keep in mind that we can cross it. What we're more focusing on with the horizontal asymptote is the long run behavior of the graph. So as we talked about with our polynomials, we're going to do that here too, where the short run behavior is what's happening in here, so like zeros and vertical asymptotes, and we'll talk about some other pieces. But long run behavior is what's happening out here at x equals negative infinity and x equals positive infinity. And what we can see is when x is out at negative infinity, our function is getting closer and closer to y equals 0. So that horizontal asymptote's defining kind of the relationship out at negative infinity as well as positive infinity. Our function's getting closer and closer to 0. But then the idea will be when we look at short run behavior, maybe we cross it and then start approaching that value. But it would be a horizontal asymptote because we're kind of focusing on what's happening at the edges of our graph with that. Whereas vertical asymptote is occurring in kind of the middle part of the graph, so that's going to be part of our short run behavior. Now, if we look at dealing with odd powers here, we can see we have a vertical asymptote at x equals 0, and we have a horizontal asymptote. Again, kind of looking at the edges here, we can see no matter what power our function is, if it's an odd power, it's getting closer and closer to 0. Same thing over here. getting closer and closer to 0. And notice that you can approach it from either side, either coming from positive values and getting closer and closer to 0. And down here, it's that we're at negative values, but still getting closer to 0. So that's our horizontal asymptote at y equals 0. So for these two types of functions, what I defined for our vertical and horizontal asymptote over on the left-hand side is the same for the odd powers. Same exact thing. All right, so let's look at some graphs of our kind of basic rational functions and talk about these asymptotes a little bit. So with this first function here, our basic function would be having just x in the denominator. So for a basic function, I'm thinking of 1 over x, and if I just put a quick sketch, that's where it's an odd power, so our graph would look something like that. We're adding 2 to x in the denominator there, so the shift that we're doing here is moving to the left by 2. So what I could do is think about my standard 1 over x graph, but we're moving everything to the left by 2. So with this horizontal shift, it's our vertical asymptote that's going to move. So I usually have this vertical asymptote at x equals 0. Now we're moving it to the left 2 spots. So now we're going to have this vertical asymptote at x equals -2. So we have this line that we cannot cross. The horizontal asymptote doesn't move at all. We would need a vertical shift to do that. So we have this horizontal asymptote at y equals 0. Now, in terms of kind of the basic structure of our 1 over x form, I keep these kind of key points in mind. So like we would have 1, 1 if we were over on this side of the graph. I need to still shift this. And then I think of about 1/2, 2, and then it would be like a third 3, a fourth 4, things like that. At 2, we'd be at a half. At 3, we'd be at a third. And at 4, we'd be at a fourth. So we want to take those same points, but graph them over here. And what you could do is kind of visualize that where these asymptotes intersect is like our origin. So like if I wanted to graph 1, 1, it's right there. Because in terms of the center of where those asymptotes intersect with each other, it's like going over 1, up 1, and then like half 2, third 3, fourth 4. At 0, we'd be at a half, and then a third, and a fourth, and so on and so forth. So with my graph over there, I'd be very close to the vertical asymptote, but not crossing it. And then over here, we're getting closer and closer to 0 as we go off to positive infinity. And then we'd have the same setup, but down here. So 1, 1 could be kind of right there, and then a half, third, fourth, half, third. Oops, kind of missed that. There we go. So something like this. Now, in terms of describing the long run behavior, looking at those asymptotes, so remember with long run behavior, it's as x goes to negative infinity, and then we're talking about what the function's doing. And as x goes to positive infinity, what's the function doing? And the question didn't actually ask for this, but we're just going to discuss it here. So with polynomials, what we had is we had the values negative infinity and positive infinity as kind of the only value showing up there. And I made a quick little comment at one point that we could have numbers coming up. And that's what we're going to be seeing here. With these horizontal asymptotes, if they exist, then we're going to be approaching a number in the long run. So in this first case, so as x approaches negative infinity, so as we're going up to the left here, my function values are getting closer and closer and closer to 0. So what we would say is r of x approaches 0. And then on the right-hand side, looking as x goes to positive infinity, the outputs for the function are getting closer and closer to 0. So with that, we would say r of x approaches 0. So that's how we could describe the long-run behavior with that horizontal asymptote. Let's look at one more here. So with this one, we have for our basic function 1 over x, and that's being squared. So for my basic function, I'm going to think about 1 over x squared, which is our graph where we have our two pieces above the x-axis. If we're subtracting 3 right next to x, so that's going to be our horizontal shift. So that's going to be a shift right by 3. And then by subtracting 2 on the outside, that's going to be our vertical shift, so down 2. So my vertical asymptote, which is usually right here at the y-axis, that's moving to the right 3. So now it's going to be over here. And now with this one, since we have a vertical shift where I usually have my horizontal asymptote, that's going to move down 2. So what we can see is where our asymptotes move to. And again, we could do kind of the same thing if we understand how 1 over x squared works. Then we can graph it as if this is our new origin, the intersection of those two asymptotes. So as a refresher with 1 over x squared, so we would have our 1, 1 if, again, I'm here back at the standard origin, and then we'll talk about shifting it over. If I was at 1/2, that would be at 4, so this changes a lot faster than 1 over x. If we're at 2, so that would be like 1 over 2 squared, which would be a 4th. So we get close to the x-axis pretty quickly here. So I'm just going to think about those 3 points, like 1, 1, and at about 1/2, 4, and then 2, 1/4. Something like that. So for this graph, it goes off to infinity pretty quickly over here, and then it also goes close to that horizontal asymptote pretty quickly. And I'm going to do the same thing, but on this side, I can't actually see one of those points, but it's like about there, and then about there. So with this graph, we're going to have something like this. We're just getting a sketch going here, so not too bad. All right, so with this one, let's talk about how we would describe the long run behavior. So as x goes to negative infinity, r of x goes to, and as x goes to positive infinity, r of x goes to. So as x goes to negative infinity, so as we're going off to the left here, what is our function doing? Well, it's getting closer and closer to this output of -2. So our function's approaching -2. And on the right-hand side of the graph, as x is getting larger and larger and larger, our outputs for our function are getting closer and closer to that horizontal asymptote, which is at -2. Just approaching it from 2 different sides. And I realized I just messed up and graphed that on the wrong side of the... It's not going to change too much, but as I was saying it was coming from below and above, but with x squared, we should only be above. So quick correction right here at the end. This would be our 1, 1. Okay, and at 1/2, we'd be at about 4. And then about there. So here's the correct one. My graph would have worked if that was for 1 over x as our basic function, but we have 1 over x squared. So it doesn't change the long run behavior. It's still -2 on either side, but we should only be above that horizontal asymptote because of that square in the denominator.